Hi, my name is Sadman Binzaman. This is EL6303, Assignment 3, Question 2. X is a random variable with probability density function defined as small f of x equals e to the negative x plus 1 unit step function of x plus 1. We're also given that y equals g of x, and g of x is defined as being absolute value of x from the interval of -1 to 1 or 0 everywhere else. The graph of small f of x, again e to negative x plus 1, unit step function of x plus 1, is pretty straightforward. Because of the step function, we're not interested in anything beyond -1. So our graph will look something like this. Similar to, and g of x, we were given up there. The graph for that is pretty straightforward as well. We'll have -1, our intervals -1 to 1. From that interval from -1 to 1, the graph of g of x is the absolute value of x, and past those points, it's 0. The first part of the question asks us to find and draw small f of y, and second part is draw capital F of y. We're going to go about by doing the second part of this question first, by finding capital F of y. For this, we need the probability of capital Y to be less than or equal to y, which is the same thing as the probability of absolute value of x being less than or equal to y, or y equaling to 0. The absolute value of x, this relationship right here can be rewritten as the probability of negative y less than or equal to x less than or equal to positive y. And this right here is the probability of x greater than 1 plus the probability of x less than -1, which equals capital F of x of y minus capital F of x of -y plus the integral of 1 minus the integral from -infinity to 1 f of x, small f of x dx, plus, ran out of space there, I'm going to write on the bottom, plus the integral for this part right here, from -infinity to -1 of f of x, x dx. This part we could completely ignore because small f of x equals 0 from the interval of -infinity to -1. After crossing that part out, we're left with capital F of x y minus capital F of x -y plus 1 minus the integral from -infinity to positive 1 of f of x dx. This right here is the same thing as the integral from -1 to y. Again, the integral should be from -infinity, but because of our unit step function, we can disregard everything before -1, so we'll just set our lower bound to -1. Again, capital F of x of y is the integral from -1 to y of e to negative x plus 1 dx. Same thing over here. Again, we're going to disregard anything. We're going to discard the lower bound, and we're going to set it to -1 because we can disregard everything because of the unit step function. This is going to be -1 to -y of e to negative x plus 1 dx, and we can just carry that last part over, 1 minus f. Again, we can rewrite this integral. The interval we can redefine from -1 to 1. Same reason as before, which becomes e to negative x plus 1 dx. Now it's just a matter of taking the simple integral of e to negative x plus 1, which is negative e negative x plus 1. Our value is going to be from -1 to positive y minus negative e to negative x plus 1 from -1 to negative y plus 1 minus negative e negative x plus 1 from -1 to 1. Now we could just set this up as negative e to negative y plus 1 plus 1 plus e to the y minus 1 minus 1 plus 1 plus e to the negative 2 minus 1. We can cross out certain terms and we're left with, well, here I'll cross these out. And we're left with negative e to the negative y plus 1 plus e to the y minus 1 plus e to negative 2. Our capital F of y is defined to be negative e to negative y plus 1 plus e to the y minus 1 plus e to negative 2 from the interval 0 is less than y, which is less than 1. It's 0 when y is less than 0 and equals to 1 when y is greater than 1. From that, we can graph our function, and it will look something like this. Well, let's just mark our points. This is going to be 1. That's going to be 1. Let's see. At 0, let's just use some markers. At 0, we're going to go with this over here. That should give us e to the negative 2. At 1, we're going to have it equal to 1. And after 1, it just sustains when. So it'll be something like that. The first part of this question asked us to find small f of y, which is another way of small f of y is the derivative of capital F of y, which equals, we just take the derivative of each term from our previous, sorry about that, small f of y is the derivative of capital F of y, and we just take the derivative of each interval, which is defined up here, and we're left with e to negative y plus 1 plus e to the y minus 1 for 0 less than y less than 1, and it's 0 everywhere else. Keeping that in mind, it's pretty straightforward to graph our function. Well, this can be f of, and we're going to have something like, let's see, at 0 it's going to be right a little bit less than 1, and it's going to be something like, at 1 it's going to equal to 1 minus e to the negative 2, so it'll be something like right here, and then it's going to sustain at 0 for the rest. And this shift up here is because of the delta function that exists. I apologize for not being a little bit more concise. I was running out of time, but thank you for watching.